Hi guys, so today we're looking at Scratch. What exactly is it and what can you do with it? Scratch is a programming language. It allows you to create things like interactive stories, games, and animation. It allows you to have content which is uploadable online and suitable for online play. The Scratch program actually facilitates this, and the Scratch website actually allows you to upload your projects. Now, quickly I can show you on the Scratch website. If I go here, there is an option called projects, and I can see a list of projects that has already been created. Moving on, where did Scratch actually get its name from? As you can see, there's a quote here which simply says, "We take the name Scratch from the way that hip-hop disc jockeys scratch with music. They take pieces of music and then combine them together in unexpected and creative ways." That's a quote by Michel Risnick from the Lifelong Kindergarten Group at MIT. Now, that gives you a hint into our next topic. Who created it? Now, looking back, we can see that Scratch was actually created by the MIT, which stands for the Massachusetts Institute of Technology. Let's have a quick look or a quick glimpse at things that you can actually do, or games that you can actually create with Scratch. Now, there's a game that I created for one of my classes. It's called Pong with a twist. It's a two-player version of Pong. So what I'm using is my arrow keys, and I'm using the WSD keys to actually play this game. I'll start it and quickly demonstrate that to you. Now, as you can see, this is a fully playable game. That's just an example of something that you can actually create using Scratch. Now, what we'll do is have a look at the layout of Scratch. The interface of the Scratch application is very intuitive. On the left hand side, we can see the block palette. It comprises of 8 different blocks in which we can select. For example, motion. The motion block is color-coded blue and only deals with things like movement and position. Variables, for example, that allows you to add values. For example, a score. You can create a variable, maybe score, and you can give that a value. This refers to language. Here, save. We can share, and as I mentioned prior, we can actually upload our content to the Scratch's website, and the standard file, edit, share, and the help menu. We can actually duplicate sprites or objects by simply clicking and clicking on duplicate, and as you can see I now have 2 of them. Now I can actually delete them as well by clicking on it, and that's gone. Sprites, I can also grow them and shrink them again, and I can make them smaller. The stage, this is where your creations come to life. This is where you would actually see your game being played or carried out. The flag, green flag, primarily what's used to start things when you create games in Scratch, and you have the stop, which as it says, it stops everything. It actually stops all the scripts as you run them. Now the lower right hand side is the sprite list, and now this allows you to quickly view all the sprites that you have in this particular game or this particular project that you create. And your stage, you're only given one stage, but your stage can have backgrounds. For example, if I click on stage, background, there is only one, but I can change that. Now a stage has backgrounds and a sprite has costumes. As you can see, this sprite has 2 costumes. Now the difference between them is not a lot, but it's enough to show the power of this application. The largest area is your script area. This is where you actually create your scripts. For example, if I click on control, and I can drag and drop my scripts. And I can continue to do that until I've achieved my goal. Now the code that you create is fairly legible. What this tells me is when I click on that green flag, i.e. the green flag, my sprite will move forward 10 steps. He would also then turn 15 degrees, and you would then point in direction 90. Let's give that a go. So I can click on that, or I can click on the flag. And my sprite actually did move, but the turn is so small, you probably didn't see it. But he is actually turning. Now, what I can do is remove the point in direction 90 degrees. I think this is actually what's stopping it. It's actually turning, and then it points straight back to 90 degrees, and as a result we don't actually see that movement. There we go. Now if I wanted to show the movement, what I could do is possibly either wait and maybe change the time from 1 second. That might be a bit too big. I can change that to maybe something like maybe 0.5, half of a second, and I can put it back. And now move forward. He moved, and then he moved back. Let's see if I change that to 1 second, what happens. There you go. Now, for me to simulate animation, what's imperative for me to do is make use of the costumes. At the moment, I'm not doing that. My sprite is merely using 1 costume. If I stop the script completely and remove these, you can detach them quite simply, and you can delete them by right clicking and selecting delete. Alternatively, you can actually drag and drop them, and that removes them as well. Now, as I mentioned before, everything is color coded, and that aids the use of this software. Makes it a lot easier for you to read and understand. Remember, Scratch was initially developed for kids as a means of introducing programming to them. Now what I would like to do is simulate animation or movement with my sprite. Now the way I can do that is to make use of both of my costumes, make use of the control block, and make use of motion perhaps, and maybe I can make use of next costume or switched costume. Now I can have my sprite move, maybe 10 steps should be fine. If I click on that, he moves, I can see him moving, but it doesn't look as if it's animated in any way. Maybe I need him to switch the costumes. I can do that by using looks, and I can add next costume, and he does, and slightly animated. We are getting there. Just gonna bring him back. Now what I could possibly do is slow him down a little bit. Maybe let's change that to 5, and if I want this to happen independently, maybe in the control block I can make use of forever, perhaps, the forever loop. Now to use forever, there are certain bits of this that I would want in the forever block. Now I can move this, and I can add it, and then add that. Alternatively, what you can do is spread that together, and the forever will add itself. The program takes care of the rest. Now let's try that and see what happens. So when I click the flag, my sprite is moving, but maybe it's happening too quickly. Now I can't slow that down. Maybe I can make use of the wait command. Let's try that. Now that works, but perhaps that's a bit too slow. Let's wait. Just make the wait time less. There you go. That's better. Try and make it even smaller. 0.2. And that's a simple example of simulating movement and simulating animation using Scratch. Now there's a lot more that you can do with the costumes. For example, if I had another costume of the movement of the legs, I could possibly add that. I can make changes to it. If I made the legs slightly shorter, then the movement would be a bit more refined. This is a simple example of what you can actually do with Scratch. The program allows you to do a lot more, as I showed before with the Pong game that was created. Now for a glimpse at another game that shows animation. Here's one that I pulled from the Scratch's website. its guardian. I know you can't see the end at the end, but I'll just quickly show this to you. Now as you can see the birds, you can see the movement with their I'll quickly stop that. Now the birds, you saw the movement with their wings as they flap about. Let's have a look and see how many sprites, sorry, how many costumes each has. And there's 9. And again, there's 9. So each bird has approximately 9 different costumes which are used to simulate the actual wing movement.